All right, we're going to begin working on proofs. We've already figured out that there were 4 ways to prove triangles congruent. We already looked at these in the previous video. There's SSS, SAS, ASA, and AAS. And now S stood for side, A stood for angle. So when you have these 3 components out of the triangle, you're able to prove they're congruent. So let's go ahead and start with this first one. Take a minute, draw the picture, label your given, and label it on the picture also. So C is a midpoint, and AD is congruent to DB, and that's our given. So what do we know? Since C is a midpoint, I know that it's halfway between A and B, meaning these 2 are congruent. AC is congruent to CB. And that's because of definition of midpoint. Now, my ultimate goal is to prove that this left-hand triangle ADC is congruent to BDC, the right-hand side. So, in order to prove triangles congruent, I need 3 things. Right now I have 2 sides, so I'm either going to use side, 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 or side, angle, side. Now for me to do side, 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 I would need to use this 3rd side, which is in the middle, or for side, angle, side, since A is in between, I would have to use angle A and angle B. Now there is a way to do angle A and angle B because this entire triangle is an equilateral triangle. We'll get to that in a little bit, or isosceles triangle. We'll get to that in the next section. But for right now, I want to say that CD is congruent to itself. Because the triangles are adjacent, they're touching, they share a common side, CD is congruent to CD, and that property is reflexive property. Now I have 1, 2, 3 sides in the left triangle, 1, 2, 3 sides in the right triangle. So I know that triangle ADC is congruent to triangle BDC. And I used all 3 sides of the triangle, so that's side, side, side congruency. Similar setup, start drawing the picture, start writing your given, and then we'll do the proof together. So since these both bisect each other, I know that BD is bisected, and I know that AC is bisected. So if BD is bisected, I know that these 2 are congruent. So BE is congruent to ED, and that's because of definition of bisector. Now, I also know, since AC is bisected, I know that AE is congruent to EC. And that's because of the same reason here. Whoops. Definition of bisector. Now I have 2 sets of sides, so I would either have to use side, side, side and use these 2 sides on the far left and far right, or I would have to use side, angle, side. And I'm actually going to use side, angle, side because these 2 angles, I'm going to number them 1 and 2 just to save some writing. I know 1 and 2 are actually congruent because they're vertical angles. All vertical angles are congruent. And now in my left-hand side triangle, I have 3 things. My right-hand side triangle, I have 3 things. That means that those triangles are congruent. So my final step, step 5. That doesn't look like a 5. There we go. We got triangle ABE. congruent to triangle CDE, and I used two sides and an angle, so it's side, angle, side. Now my next proof, we got DC is perpendicular to AB, and AC is congruent to CB. That's my given. So I'm going to label that DC is perpendicular, AC and CB are congruent. So what I have here, I have two right angles. So I'm going to number those 1 and 2. Angle 1 and angle 2 are right angles. And the reason they're right angles is definition of perpendicular. And now that they're right angles, 1 and 2, I can say that 1's congruent to 2. And the reason they're congruent is all right angles are 90 degrees, so all right angles are congruent. So I've got two things in each triangle. I've got an angle and an angle. I've got a side and a side. I need to find a third thing. I could either use an angle, I could use another side. Because the two triangles are touching, I'm going to use this middle side. So I'm going to say that DC, DC is congruent to DC, and that's reflexive property. And now that I have three things, side, angle, side. So triangle ACD is congruent to triangle BCD. And that's by side, angle, side. Now our last example in this video, we have two triangles that are touching again. So I'm going to start to look for right away using reflexive property. So CD is parallel to AB. So we're going to use our parallel angle properties also. I know that CD is congruent to AB. So let's write those. CD parallel to AB and CD congruent to AB. And that's given to me. Step 2, let's go ahead and use our parallel lines as a property. Because the top and bottom are parallel, I can say that angle 2 and 1 are congruent because they're alternate interior angles. Step 2, if parallel, if parallel, alternate interior angles are congruent. So I know those are congruent. 3 and 4 probably are congruent in the picture, but I can't say anything about 3 and 4 because CB and AD, I don't know for sure if they're parallel. Since it's not stated and it's not given to me, I can't say that those are parallel. So now what we have a side, an angle, and then I talked about reflexive property. We're going to use that. We're going to use that the middle side, AC, is congruent to itself. And that's reflexive property. So we have a side up here, we have an angle, we have a side. I'm going to use side, angle, side. And that is triangle ABC, congruent to triangle CDA.